So my name is Bradford. I'm Director of Technical Marketing here for the Digital Experience team for Pure.
I'm Payal Srivastava. I'm part of the product management team at Pure.
And so we're going to be showing off the new sustainability assessment that we've recently launched within Pure1. But first, we're just going to set the stage, talking a little bit about sustainability and climate change and how it's a real threat to us, right? Time's not going to stop. Wait for us to try to figure things out. We really need to try to, get a handle on all of our carbon usage here. Because honestly, like if we don't change anything, if we don't change our, reduce our carbon emissions, some experts are saying we could see 4 to 6 degrees Fahrenheit warmer across the globe by the end of the century. So, the things that means things like droughts, right? More heat waves, you name it. And if you're like me and you live somewhere that we're not really all that impacted by these types of things, so climate change isn't real. We don't necessarily have droughts like you all have. It's
multi-year.
Yes. It's still gonna kind of reach us one way or the other because think of where our food comes from and how crops are impacted by this. So one of the interesting things is that data centers make up about 1% of the Earth's energy usage. 1% doesn't sound like a whole lot. It doesn't sound like it's an IT problem as far as reducing, energy usage. We're only at 1%. There's other industries like, manufacturing that uses up huge amounts of energy, right? I used to work on CNC equipment and we'd strap 400 amp and sometimes even 800 amp lightning generators to these things to melt steel with electricity, right? We're not doing that in our data centers, or at least, not doing that on purpose. Let's put that 1% into perspective. That 1% is more than some countries actually consume for energy altogether, right? So it's still a pretty significant number. And if you want to look at things from a sustainability standpoint, or if you want to look at things from a lot more at the macro level and look at your business, right? We know energy prices are up. We know that we're starting to see that energy is very finite, right? We're starting to see a lot more of that. So think about what your company consumes for power and how much of that is going into your data center, right? So, for example, I think Facebook was in their 2020 sustainability report. If you look at all of their power consumption, 97% of it goes just to feeding their data centers, right? That's obviously pretty huge. Not every company is going to be seeing something like that. But if you're looking at ways to, save your money, lower costs and everything, start looking at, how much of that power that you're paying for every month is going into your data center. Now it starts to become a real problem, right? If, whether you're interested in sustainability, maybe you're trying to meet, EU requirements, or if you're trying to look at how to save your business money, all of this becomes real to everybody.
Now, just to put things in perspective, we may not be, using the blazing guns to melt steel, but, our data centers are running 24/7. The volume of data is increasing, the power, the infrastructure is increasing. So we are very much contributing to our climate change, to the so sustainability is extremely important. It's also important, we hear a lot about, this data center where people are buying carbon credits or using renewable energy. However, the cost of energy is another aspect that does go down into the customer, into the user's perspective. So keep that in mind. So at Pure, we are absolutely committed to building sustainable products. We start from the point of design, our life cycle analyses, our life cycle processes, as well as use phase analysis. All that we have taken into consideration. And in earlier this year, we released our ESG report for 2021. And the commitment that we have is that we are going to reduce our carbon footprint by 50% by 2030. We made this report available on our website, and we are going through ISO certification for the sustainability ESG report, which should be soon coming out to folks. So if people are interested, we will be ISO certified. This analysis has been conducted by a third party called WSP, and it is a very well-known recognized company in the industry for sustainability analyses.
So should we jump into the numbers?
Yeah, let's do that.
Awesome. So yeah, I mean, really kind of from the beginning, we've been designing storage with power in mind, right? We built everything knowing that we're going to be starting with all flash, so we can build the hardware, we can build the software together. And through this work with this third party, we wanted to figure out where in the marketplace Pure stands, right, as far as energy consumption goes. And what we found is, with them looking at our all-flash storage and comparing it to competitive all-flash storage, right? We're not looking at spinning disk or trying to inflate numbers or anything. We found that we're about 80% greater energy, savings using Pure storage. And the way that we're doing that, again, we're kind of designing this for flash, right from the get-go. We're not taking storage arrays that were built for spinning disks, slapping SSDs in there and saying, we're ready to go. We're taking advantage of the technology. So using things like, our data reduction software, right? We can actually reduce the overall raw capacity that you need. And then also using like quad level cell technology, QLC, right? We can get really, really dense with our hardware. So we're cutting down on, not just power, not just cooling, but also your data center footprint as well, which, as we know, if you look at the square footage cost of your data centers, not exactly cheap these days, right? So we can really cut down on a lot of that. And so that 80% number actually turns out to be fairly conservative. When we looked at the entire life cycle of our FlashArray X70s, we looked at everything from manufacture to use case, one of the things in production, as well as when it comes time to decommission and dispose of, which we do things very differently here at Pure. We'll get into. Right? We looked across all of that, again, all flash to all flash, competitors that we see in the field all the time, and it's actually 84.7% energy savings. And again, comes down to designing everything, for all flash kind of from the get-go. Now, if we look at other lines like the XL is 80%, and then if we look at FlashBlade C, we're looking at like the use case lifecycle for these, is 75% over hybrid competition. And then with FlashBlade S, all this carries over to the new FlashBlade S line that we launched recently, and we're looking at about 67% energy savings. So Payal, do you want to kind of try to put these things into perspective here?
Sure, Matt. The numbers are great. We can look at the analysis based on, and a lot of these numbers have been, when we talk about efficiency, we're talking about the products that we compete with in the market, supported through our LCA analysis. But in all reality, I mean, what really we are talking about is, saving the environment. 873 trees, growing for 10 years. That's really the big impact here. The number of miles, you can see the average passenger vehicle. So overall, there's like a multiplier effect for any type of savings that we are doing in terms of sustainability. Once again, the impact is with a better design, with a more with the evergreen architecture that we're going to talk about, there is a initial footprint is smaller, and then as a result, any of the things that cause a domino effect are also lessened in terms of design.
Yeah, talking about the kind of the end of the life cycle here, right? When it comes time to decommission your storage, and with other, more traditional type of arrays, what happens, right? You've got most customers, or a lot of customers, have like a 5-year cycle. And so what do? Well, you spend $1 million or a couple million on another array, install it next to your existing array, migrate that data over, take downtime, do the final cutover, and then you haul that entire hunk right out to the loading dock, throw it in a truck, and it gets scrapped. That never made sense to me. I mean, you've got so much more life in those power supplies. I mean, the rack itself, the chassis, backplane, right? All of that sort of stuff. Why not just replace the parts that need to be replaced? So when it comes time to upgrade with Pure, when it, really all you need to do is upgrade the storage controllers or, the storage itself.
Yeah, and in Pure1, and also we do show it to our customers. we can show a life cycle of, upgrades that they've gone, and they're all in-place upgrades. A controller has been upgraded in order to give more performance. There's additional disks, and additional SSD, additional shelves. No rip or replace. And if you see, like over years, we've shown customers, like a 7-year journey with all in-place upgrades. We just recently did a webinar, and it was a great conversation. It was with the customers online. Number of them are actually moving to even non-disruptive upgrades during lunch hours. Stan is going to talk about upgrade management through Pure1, and we've brought this capability for our customers to do purity upgrades right through Pure1. It's simple 3 steps. And the interesting part was that the customers were like, I'm doing upgrades during lunch hour. We've actually gotten an override because we have so much confidence in Pure upgrades that we've gotten an override from our usual process of trying to go in over weekends or plan out over low traffic time. They're actually just doing it during business hours, which was a great endorsement for the product.
Yeah.
Are you gonna move to a demo?
I think so. Yes, we can carry on with.
A couple of questions.
Yes, sir.
So you're giving for granted that your, approach is 100% unique, but even if it's unique, I mean, in the moment you replace old SSDs or old controllers, this is electronic waste anyway. I mean, so it's not that you are replacing the controller that is power supplies and a chassis and probably some other components, and you can have a granular approach to this, but actually it's not 100%, and in the end you have some components that are left anyway that has to be taken into account, while you implied that your approach is 100% green.
Sure. I mean, it's
And many vendors now allow you to I mean, they copied you. I mean, you were the first in the market, that's for sure. But I mean, they are coming to the same conclusion, ideas, and they are, at least from the marketing point of view, they are programs that looks more similar to yours than in the past. So, I mean, so if you are comparing apple with apples,
I think it's also first of all, there is always going to be some level of waste, right? We have to upgrade a controller. Now, can we reuse the controller in a different way? We do try to do that, but you're right. If a controller has no use, then it is going into e-waste. So the implication is not that it is zero waste, right? Let me put that clearly. However, we are very much, based on our customer endorsements, we are very, very simple. We have ability to do upgrades within a couple of hours. And now with upgrade management, like we are actually doing software upgrades right from the cloud, very, very effectively, directly, the customer can do it. No professional services, no install services, none of that is required. So there is uniqueness.
Sustainability in the sense of power efficiency, right? So I want to separate the two. I mean, flexibility, efficiency in terms of operations, and that there is efficiencies in terms of power efficiency. When you have the green slides, you talk about power efficiency mostly, right?
Yeah.
So these are two different discussion. I mean, you're mixing up a few things here.
No, in terms of like if you're doing data migration, if you're having another system on standby, then that is not as power efficient, right?
No, yes, 100%. But you're talking about making a system update, like upgrading the firmware. Nobody's stopping systems anymore.
Well, I mean, it could be upgrading firmware, and again, we're going to show you that in the next demo, but also for complete hardware. So yeah, I mean, to your point, right? It's not zero waste. There's still that assembly that needs to be replaced. I mean, I guess we could ship SMDs, but yeah, there's still going to be some waste there, but yeah.
Okay.
So
And you're comparing your system, just to be clear here, with the other 2 controller system, because if I have 8 controllers and I don't need 1 controller running all the time without doing practically anything, which is 50% of my energy wasted to, warm up some air, then it's a totally different, because there are some vendors that have multiple controllers. So if I take 1 controller out, 1 of 8 or 1 of many, I just have a minimal stop, and they work in parallel usually. So probably there is a huge difference in how you calculate the power efficiency in that case.
Yes, and you're going to see as part of the demo, we've also gotten, your questions are also alluding a little bit, and correct me if I'm wrong, to the density and to the amount of storage that we support by model, right? I mean, it's whether it's 8 controllers, whether it's 2 controllers, it's about performance and density as well. And we can. That's a longer conversation, but at least in the assessment, what you will see is, not just the typical usage in terms of power that we benchmark, but also the actual usage that is being reported for the system. And in addition, Matt's going to also talk about the configuration. We're showing the rack space, the rack units that are being used in order to provide a certain level of density as well. So we are trying to be as transparent in the configuration, in the rack space, as we can, based on, and this has been vetted with a number of customers who are looking at sustainability reporting. And one of the things that I would say is that since our GA for this particular feature, we have become more aware and more informed about all the different ways that IT groups are becoming more stringent in terms of in terms of power reporting, as well as sustainability impact reporting into their sustainability departments. So the rack space, the typical usage, the actual usage, the changes in configuration leading to changes in into the power profile are actually being shown here as part of the demo and as part of the product. So it's all live.
Actually, so I have a couple questions. So in regards to the sustainability of the product, in general, in computing devices, fans take up a lot of power. So a couple things. Is there anything that you guys are doing within your devices? Say I've got a data center that's ultra chilled, right? And I'll get into liquid cooling in a minute, but if I've got a cold data center and my fans don't have to run at the full speed that they normally run, do you guys have anything in your product that would reduce the amount of power that the system consumes in order to recover some of that? Because I can run at a lower power rate. And second of all, are you engaged with any of the, and not necessarily fully submersible, cooling environments, but perhaps some things like Open19v2, some of the cooling networks to get the power supplies and fans out of your systems altogether, feed in, let's say, a 48 volt, a feed that would get the PUE weight like below 1 from the compute perspective, right? Which is really the biggest bang for your buck from a power perspective, which actually right now, especially in EMEA, where power just went crazy, I think we're seeing almost 100% jump. Customers, that becomes not just a sustainability play, but a real financial situation. What are you guys doing on all that?
Yeah, no, those are fair questions. I mean, the reason why I'm smiling is because these are the type of conversations that have started happening. We started with ESG report. We started with the sustainability, transparency, and it's an effort to bring, metrics and start these conversations with customers on what type of cooling. I mean, we have some idea on what type of cooling is being used, but we are also hearing a lot of, new technology being deployed, especially in Europe, or being planned because of the power consumptions and all of that. So we don't have anything specific to share in terms of, how to bring the power profile lower while the array is running. But these are, very active conversations.
Are you having these conversations in industry as well? Because I mean, you guys have kind of led the industry in this whole journey to be more efficient.
Yes.
But it seems like instead of it being a competitive advantage, which of course that's great, you guys are figuring out to do it. It seems like for the Earth's environment, it would be good if the whole industry worked together instead of competing against each other.
It's absolutely a great sentiment, and we share that sentiment too. So actually, in one of our blogs, that's really, what we are also bringing out. The intent, like I said, the power cost just went up the roof, but the intent was really to start becoming more transparent in terms of sustainability. And there are now conversations starting in terms of, sharing more with the industry, bringing visibility into the power profile, real-time visibility. I think this conversation is going to move towards more of, saving our planet Earth and the climate, rather than, really talking about, sure, there's a little bit of healthy competition, but it's more about, how do we make this more efficient? So the dialogue's moving, but this is just our first step. And, and we are pretty much, the first in the industry to actually bring this much transparency and this much visibility, because it's no more spec sheets. It's actually what you're using. We're showing, what's being consumed.
No, for a good marketing standpoint, you could have the first fully consumer enterprise ready storage system that's fully submersible.
Yeah.
So think about the marketing aspects of that.
Awesome.
Will do. Yep.
That's a whole other conversation we could have. That's
Yeah,
not
just
necessarily
put the array in mineral oil.
Yep.
Done. Yeah.
I mean, it will be certainly interesting to see a lot of these technologies get adopted more and more. I mean, Intel's, what was it, Emerald Rapids, I think they're looking at like in the 350 watt range. So, I mean, we're starting to see a lot more consumption within, I mean, certainly GPUs too. So I think we're going to start seeing a lot of adoption of these types of technologies. That's going to drive the industry as well. So, kind of jumping into the sustainability assessment here, we're looking at Pure1, which is our free, really kind of storage management tool for, looking at things like capacity, performance, data protection, as well as other things like Portworx, right, for Kubernetes, and for like VMware, looking into those environments. And again, free tool that we offer to all Pure customers. We don't charge for any of these assessments or nickel and dime or anything. So we're going to jump into the sustainability assessment. And actually, we've got two assessments within the product. So the first is the data protection assessment. And what this does is kind of looks across your entire fleet of storage and make sure that you've got protections in place for, I don't know, pretty much whatever could happen. If it's malware, right? We've got things like immutable snapshots through safe mode, and then also things like replication. So we've got a lot of like recommendations in here if we need to do any upgrades, or if we need to create some space for enabling some of these features. All of that is in this assessment here. But what we're talking about today is the sustainability assessment. So within the sustainability assessment, all right, we start off with just kind of an overall view of the entire fleet of storage. And so each of the hexagons represents an array, right? We've got some that have actions that are required. We've got some that have some recommendations. And so this assessment isn't just about, here's the raw data, right? This assessment is about, we want to try to help you to get the most out of your storage, and we'll make these recommendations, which we'll jump into. Then we've also got the total projected power. So again, this is across your entire fleet, no matter where your storage arrays are running. But if you get that C-suite asking about power consumption, right, you can break it down right here to see what your storage is consuming for Pure Storage. And this is looking at the entire year, right? We can also calculate the power savings. So again, this is kind of using those efficiency numbers that we talked about in the beginning of this presentation. We don't know what other sort of storage arrays you've got, so we're using the numbers that we've got. And we also calculate the direct carbon usage. So if you're using a lot more renewable energy, we can actually kind of change this meter here and figure out what your direct carbon usage is. And that equation is based on a multinational standard equation to figure all of that out. So that's kind of everything at like sort of the whole.
Do you have anywhere on here that actually shows how efficiently you're actually using the resources that are in the arrays?
Yeah,
Right.
so actually we'll get to that. We've got some cool numbers here to show you. So that's everything at the global level. But then we can jump in to each of the data center levels. And Payal, that would be.
It was because of the power cost profiles that you were talking about, right? Europe's cost went up, and there's different guidelines from different environments, from different countries that are being followed for ESG. So one of the requirements from our customers was to really look at the profile, not just at the global level, but also at a data center level, at a regional level. And that's why we added that in.
Yeah, and then also for requirements too, right? I think what EU's got some requirements by 2030, so we can kind of break things down regionally that way. So we can take a look at one of our data centers here. So we're going to look at the one in Sunnyvale, and here's where we can really kind of break things down and figure out what our costs are. Because obviously, like Payal said, prices are going to be different for different regions. So we actually break down. I'll zoom in here a little bit. We break down your actual total power consumption for this one data center. So in this case, I can see how many kilowatts we're leveraging, but then also to provide a barometer. We'll give you the total peak power. And this is based on the specs of those arrays, what they're rated for peak power. So it just kind of gives you a little frame of reference here of how you're performing. We got the total number of rack units here. So we can look at maybe some ways of consolidating that. And then we can calculate the heat too, because we know what your power usage is. And we can kind of calculate the heat. From that, again, we'll give you a peak, and then your actual heat usage, and then your usable and used capacity here. So scrolling down, we can see all of our different recommendations for all the different arrays. So for this site, maybe this one has some of the most expensive power. I want to focus in here. So we've got the recommendations for each of these arrays. But what I can do is, we'll jump into the recommendations in just a minute, but then we can also look across all of our data centers. So again, we can sort of look at what is our most expensive, but probably is where we're going to want to start as far as looking at what data centers to focus in on. So we've got that entire breakdown here. We can see what the total power is for each data center. And then going into the recommendations here. So we'll take a look at Artemis here. So we got two different recommendations. So the first one is that we're using some old SAS flash modules, right? So one recommendation would be, hey, look at upgrading these to something a lot more dense and a lot more performant. That's going to maximize your efficiency. But then also, because we're looking at the capacity utilization of your storage, look, if you're not actually using all that capacity, you're still burning electrons, keeping all that equipment running. Let's start looking at maximizing that. And we have a cool metric to show you with all of that. So let's jump into the array level metrics here. And I'm going to the list view. And then we'll take a look at Gilgarn over here, right? So I can see the model number, what version it is, the number of shelves, the number of rack units for this guy, but then also the capacity. So capacity kind of feeds in sort of down the chain here a little bit. But then also I can see the power consumption. So this guy's pulling about 1,200 watts, which is about what my toaster draws. So I've got that comparison there to also the typical, what is sort of the nominal power usage for this model of array, right? And I can turn on the peak if I wanted to kind of see what my worst case could be. Again, we're generating the heat here, right? Or calculating the heat that we need to offset with cooling. And then over here, Payal, let's talk about the watts per T and power efficiency metrics. So, there's a ton of numbers that we're kind of looking at here. And as we're sort of having these conversations of what can I do, and if I want to compare how one array is doing to another, we came up with this hero metric here, which is watts per T.
Yes, and this is just more of an indicator, right? So when you're looking at designing, when our customers are looking at planning, the peak numbers and the typical numbers are what you're going by. The actual numbers is an attempt to keep us honest and also keep the visibility, right? The configuration changes based on, the life cycle of the array. So, those power, the spec numbers may have had to change, but were never updated in the customer catalog. The power efficiency is about watts per terabyte. What this is giving is, based on actual usage, how much how much watts is being used for providing 1 terabyte of storage data. And then the very next to it is the watts per total usable. And so there's a difference, right, between how much of the storage might be consumed versus how much you are actually instrumented or provisioned for. The right number is more of a guideline given your current profile of the workload. So we are not assuming a workload profile because we do have dedupe and compression. Matt, you may want to just point to that. We do show the DRR as well.
Yep.
So given your current workload profile, what is the best, right, watts per T that you can get by adding more, by using more of the array, by adding more of the data, and also it provides an indicator of how much load there is, how much of the power are you using on the array. So it could be that you've got plenty of room in terms of capacity, and you've got plenty of room in terms of the load for the array. So given your current profile, you can get better mileage out of this infrastructure, and this is the guidance. This is basically a guiding point that we provide to the customer.
So all of this information, I know that you're showing us how to look at things from the first time and then how to get it up to date. But then when you're getting ready for an audit, is there specific format that goes in? Do you guys provide out to that, or are or does it go out to places that could help you prepare for an audit?
Yeah, I mean, as far as like exporting the data, do you mean for audits? Yeah, I mean, we can export into what, CSV, PSD. Yeah, yeah, and API calls as well. So yeah, so this information is available.